Hello, and welcome to a GED specific Newton Mathletics video. This is Lee, and I want to dedicate this video to you. I applaud you for taking a step in the right direction and clicking the play button. Yay you! Okay, so remember, math is just a language. Once you understand how to speak it, it becomes a powerful tool in many different technical professions. So today, I'm going to drop some knowledge your way. Grab a pencil and pause when prompted. The GED test is not about memorizing formulas. The ones you'll need will be provided and are posted in advance. The formula sheet is a great tool, but it's not going to do the work for you. You need to be able to problem solve. So let's take a look at the resources you're given and see if we can decipher some of these foreign symbols that are smushed together, like here, which means multiply. This top section refers to area, or the space inside a shape. Think carpeting a floor or painting a wall. How many square feet will fit within the space? In a rectangle, length times width. If I've got a parallelogram, base times height. And base times height divided by 2 for a triangle, because it's just half of a quadrilateral. Here we've got a trapezoid with bases 1 and 2. Average the bases, then multiply by your height, or you can use this fancy formula, but don't forget the parentheses. This circle has a radius r and a diameter d. The area of a circle is pi r squared. Remember, r squared is just r times r. The perimeter of a shape is all about the distance or the rim of the shape. This is a length. Think meters, miles, inches. Think about fencing a yard or calculating baseboards, measuring in your house. The surface area is the sum of all the faces in a 3D figure. Think about wrapping a present. The surface area, now we're back to using that square unit of measurement. Feet squared, inches squared. Here's a rectangular prism. It has 6 rectangular faces. So you can use this formula here. 2 times length times width, plus 2 times length times height, plus 2 times width times height. Add those all together, and that's going to give you the surface area of your rectangular prism with 6 faces. Volume is the 3D space inside a figure. How much fuel is in a tank, or the space inside a box. This unit is cubic. Inches cubed, feet cubed, centimeters cubed. Identifying the right formula to use and then using it correctly is key. Next, we have data and algebra formulas. We're going to touch base on those in a minute. Take a look at that wacky quadratic formula with its squares, square roots, and negative sign. It looks more intimidating than it actually is. Take a look at this handy dandy TI-30 state-of-the-art calculator. This will be on screen up in the corner as the calculator reference. A few buttons I want to point out. The negative sign down at the bottom. The exponent is the hat button. So if you want to square or cube or raise something to the 12th power, use that button. Fractions are in the middle here. You can do a mixed number as well. Parentheses are always recommended when you're working with multiplication. If you need to find a square root, like with the Pythagorean theorem, you need to push the second button first. And sometimes you'll receive an answer that has a radical in it. Don't worry, push the button with the 2 triangles, and that will reduce to a decimal equivalency. So time is of the essence, and we can't cover everything in one video. So I have come up with the top 5 concepts that I'm going to drop on you today. Number 5 concept is number sense. Numbers are our friends, so learn to speak their language. Remember your place values, tenths, hundredths, thousandths. Also, scientific notation. It's a way to write really big numbers and really small numbers without a bunch of zeros. So to simplify into expanded form, just move the decimal the amount of times indicated in the exponent. Positive moves it to the right, makes it bigger, and negative moves it to the left, makes it smaller. So fill it in with zeros, and wow, that's a big number and a really small number. Adding and subtracting fractions. If you have the same bottoms or denominators, just add the tops, the numerators. But if you have different bottoms, well, you need to find a common denominator first, and you're gonna have to do a little bit of multiplying. So to multiply fraction, that's actually pretty fun. You just have to multiply the tops and multiply the bottoms. You can reduce before or reduce your fraction at the end. And so remember when you divide fractions, I remember copy.flip. Keep the first fraction the same, turn the division sign into a multiplication sign, and flip the second. Copy.flip. So, because to divide fractions, you're actually just multiplying by the reciprocal, which is pretty neat. The order of operations gives you a roadmap on how to simplify expressions. You can't just start from the left and go to the right. You actually need to have parentheses first, and then your exponents, and then multiplication and division. But remember, they are on the same level, whatever comes left to right. Then addition and subtraction are on the same level, left to right. Woohoo! So, exponent rules. We've got the same base. Add those exponents. You've got a power rule here. With parentheses, you would be multiplying the exponents. Square root literally means you have the area of a square and you want to find the side length. The area of this square is 49. The square root of 49 is 7. Cube root literally means you have the volume of a cube and you want to find the side length. This cube has a volume of 8. So the side length, or the cube root of 8, is 2. 2 times 2 times 2 equals 8. Undefined is a bit of a dark term in mathematics. You can never divide by 0 or square root a negative. It's just undefined. So remember that and obey the rules. Concept number 4, probability, statistics, and data. Mean is the average. Add the values that you have, divide by how many entries, and that's the average. The median is the middle number when ordered from least to greatest. If you have an even number of entries, find the average of those two middle values. The mode's not given, but it's the entry that occurs the most. The mode is the most, and you can also have multiple modes. The range is the biggest number minus the smallest number. Okay, you're going to see charts and graphs. Make sure you can locate a fly on a coordinate grid. You're going to travel X and then Y. So this fly here would be 2, 3. But over here, you would have -6, 3. And this point over here would be 0, -5. These are X, Y coordinates. And are pretty handy when you're talking about scatter plots. Scatter plots display relationships between two variables. For example, height and wingspan would have a pretty strong positive correlation, whilst the value of a new car driven off a lot would depreciate pretty quickly, and so it would have a negative trend with a relation to time. And here could represent two variables that don't relate, such as height and hair length. Take a look at this box and whisker plot. These are used to display data in a visual way, breaking the data into quadrants or quartiles. 25%. So 25% of your data lies in each section. To create a box and whisker plot, you first line up the data and find the median. That's the middle value. This is the middle line. Then you find the median of the lower half and the median of the upper half. This is your quartile 1 and quartile 3. Then the minimum and the maximum dots are here to complete your whisker values. Beautiful. Now, if there are 500 people surveyed with the following results, how many of them like Raspberry Pi? Well, we have 48% times a total of 500, or 0.48 times 500. Don't forget to bring your 2 decimal places into your answer. Number 3 concept is all of those geometry formulas that we were just talking about. Perimeter, area, volume. Know the dimension you're working in, choose the right formula, and use your calculator to help, especially with those parentheses. So here we're looking at the surface area and volume of a sphere. Grab those formulas, substitute in the values, the radius here, and then use your calculator. Keep an eye out for right triangle applications where you're trying to find a side length. In this case, it's a rectangle, but we're trying to find the diagonal. So we're really breaking this into a right triangle. We need to use the Pythagorean theorem. So 18 is A, 20 is B, and the hypotenuse that we're trying to find is C. 18 squared plus 20 squared equals c squared. 724 equals c squared. So now to get rid of the squared, we need to use the square root. Find that on your calculator. You're going to need to use the second button. Second square root of 724 equals 26.907, So about 27 meters is my hypotenuse. So now if you need to find the leg and you're given the hypotenuse, your problem's going to look slightly different. Here, if I had a hypotenuse of 13, a leg of 12, I have a squared plus 12 squared equals 13 squared. A squared plus 144 equals 169. Subtract 144 from both sides, and now square root that final result to get 5. So the other leg is 5. Number 2 concept is algebra. Welcome to the world of variables. Now we're really going to mix our letters and our numbers together. But don't worry that variables are just placeholders to describe numbers. So let's start by solving a big fat equation with just an x value here. Not an x squared, just an x value. No y's in there yet, just x. So organization is key. We need to distribute first. When they touch, it means multiply. But don't forget you need to distribute all the way through. After your parentheses are gone, you're going to combine like terms. Like terms are terms with the same variable and the same exponent. Now that it's cleaned up, we want to move variables to the same side. You're going to add or subtract to keep it balanced. Remember, an equation is like a scale. What you do to one side, you got to do to the other. Now we need to unwrap this variable. Get rid of the constant by adding or subtracting. Now, divide or multiply by the coefficient, and whammo! X equals... Now let's throw another variable into the mix. Call it y. Now it's a function. I put a value in for x into the function, and chug, 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 it pops out a value of y. This generates a whole mess of points. And if I graph these points on a two-dimensional grid, these xy coordinate points, the function comes to life. You might see a straight line or a dramatic exponential increase, or maybe a wave. These functions tell a story, and the graph allows us to see them. So, to be a function, for every input, there's exactly one output. And if there's 2, it fails the test. An easy way to check is to graph it. And you can see if I slice it with this vertical line test, if I ever slice 2 points, that's not a function anymore. So you'll need to know about linear functions. And woohoo, they gave you some formulas. You've got the slope formula using 2 points. Remember to name your points first. x1 and y1 is your first point. x2 and y2 is your second point before you plug them in. And beware of negative signs. The star of the show here is the slope-intercept form. This is just a linear function, just a line. M is the slope, how tilty your line is, and B is the y-intercept, or where it crosses the y-axis. So in this example, it crosses at positive 3, and it goes up 2 and over 1. It rises 2 and runs 1. So the slope is rise over run, 2 over 1. So my linear equation is, let's put it all together, y equals 2x plus 3. Now we can find any point on the line, any point. That's so crazy. How about it if x was 1,000? So y equals 2 times 1,000 plus 3, or y equals 2,003. So the point on this line is x equals 1,000 and y equals 2,003. Whew. So how about if I need to find the slope between 2 points? But it's not on a graph. So don't worry, grab that slope formula. And here we go. x1, y1, x2, y2. 15 minus 0 equals 15. Negative 9 minus 9. Remember, that's going farther in the negatives. Negative 18. 15 divided by negative 18. Oh, well, that's weird. Let's divide by 1. So it doesn't change the value. It just changes the look of it a little bit. And that's going to be 15 divided by 3 is 5. negative 18 divided by 3 is negative 6, or negative 5 6. I always throw the negative on top because then I know that the rise is up or down and the run is always to the right. So here I would go down 5 over 6, down 5 over 6. So my slope between those points is negative 5 6. And the number one concept I need you to focus on is this. You need to walk into this test with a problem-solving mentality. You need to be persistent, don't give up, use the tools you're given, estimate the answer first using common sense, eliminate multiple choice values that don't even make sense. Here's the poster that hangs in my classroom. The steps to problem solving. First, break it down, understand the problem. You might need to draw a picture. It actually helps. You need to translate into mathematical language. Use those variables. They're our friends. Show your mathematical process. Do a reality check. Does the answer even make sense? And then state the solution. You should be doing this for every single problem you come across. Don't give up. You've got this. To pass your GED, you do have to have a general working knowledge of mathematics. The IMPACT program here at BTC is an excellent opportunity for students to complete their GED and continue their education in a technical career of their choice. The programs offered at BTC are full of math, such as Ohm's law used in HVAC or diesel tech, and dimensional analysis and yield percent within culinary. Or how about the math involved in welding, machining, or radiologic technology? It all looks pretty complicated, but it's just about deciphering the language. Practice speaking it now, and you'll be more prepared to tackle technical math in the future. Okay, that's it for me, but don't stop here. Practice with these tools and make some problems up on your own. The best problems rarely tell you how to solve them. And as always, stop and think before you leap. So for more cheesy math videos from Lee, visit Newton Mathletics. I bet you'll think they're pretty Gouda. All right, good luck, my friend.